Testing, 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 testing. All right. Uh, let's do this. Let's see. Pop that up. Here we go. Okay. So, right now, I'm trying to train. It's called a convolutional neural network to play chess using Monte Carlo tree search. And I have that working, except there's two problems. The brain, we've already we've already exceeded the bot brain capacity, which already makes me think this idea is not conceivable, because how we can't I haven't even added in the weights and biases for the network. So how can we fit that in if it's already exceeded? I mean, I could optimize it some, but I doubt it would be enough to fit a decent sized network. And the network that I am using is way too big, and it still is not performing very well. And I don't know if that's because of the architecture or if it hasn't been trained properly. I mean, it performs okay, but it likes to blunder pieces a lot. Um, let's see exactly. It seems that it's fine in the opening. Well, I mean, that what is that rook move? It's not terrible in the opening. It's not atrocious. Um, but it could be better. Like, why is it pushing this pawn? And then here it sacrificed a knight for no reason. Um, I think I just have to train the AI more. Um, I have like 22,000 positions and counting that the AI can train on. So I'm going to start the training server right now um, and begin training the AI. Right now, it's at an average loss of like 10, which is not ideal at all. Um, really not ideal. Um, yeah. Uh, I think that's because it can't really recognize um, checkmates. So if it if it's a checkmate, it doesn't really know, and it's just evaluating. It is not a checkmate. What is that error? 1,118. It's crazy. Yeah, we're just gonna let it train. Hopefully, it seemed okay. Cause like, okay, in the first few moves, like 2 moves, 3 moves, it plays actually okay. But then any time after that, it loses it, and I'm not entirely sure why. I'm thinking the problem is that I can't even fit the neural network into the bot. So should I really try to keep expanding um, this idea? It doesn't seem too bad of an idea. It just the token limit's a bit too restrictive for it. If it was like doubled, then we'd be fine. But then again, if it was also doubled, then everyone else would be like way better at bots. So maybe it wouldn't be so fine. Um, so yeah, see, one of the things is I want to try unique approaches more than completely uh, like doing what everyone else is doing with like a negamax or min-max alpha beta pruning with p-squared tables and all this stuff like that. Really I don't really want to do that because it's quite boring. Spending lots of time debugging that, trying to fit every little feature in. I like trying out new ideas like this a lot better, although it definitely seemed to perform a lot worse. Sebastian also mentioned in the challenge that uh, it's not going to be just about who's the best, but also who has the most interesting ideas. So maybe I can win based on who has the most interesting ideas. Um, but then again, that's going to be hard to really get the most interesting idea. I'm really. I need to figure out a way to fit a small neural network with a really small evaluation in like search and somehow get that to perform decently well. Because it's not performing too well and it's way too big right now. My other bot performed a lot better, but it was not very unique and it didn't perform as well as other bots. It did try and use um, reusing of states, which I don't know if how very many other bots do that, but I think that ended up just hurting it instead of helping it, even though it was a unique idea. It wasn't too unique. It also had like a not very standard expansion and like evaluation and stuff, and that kind of made it difficult to develop some things because I had to like figure out how to fit ideas into a little bit of a non-standard approach. Um, so that made it difficult. And I mean, okay. We have basically 1 month to make this as good as possible, which is that's a little bit scary because that's not too far away. Let me see exactly what the date is for GitHub chess. October 1st, so a little bit under a month. That's not too much time. Really wish I was able to have more time. Oh well. I'm gonna go explore a little bit. Chess program. Okay, so there's a few different approaches I've tried. I've tried a depth first search. I've tried a Monte Carlo search. And I've tried standard Negamax alpha beta pruning search. Although when I've done all of that, I've always had this node system where all of them like store the tree in memory and then can continue to go like iterate recursively search down that. And I think that uses more tokens than it could. Perhaps I want to look at how other bots do that. I know there's a bot called Light Blue that's open source made by someone recently that I could take a look at and see if they do also store it in like a tree, because that one's pretty powerful, a lot more powerful than mine. So I'll have to take a look at that. But just letting the bot train right now. It has an average loss of 47. That's quite a lot. And look, we can see the compressed. So there's 2,000 weights and biases. And we can maybe compress that down to 2,000 and 3,000 tokens. But the limit is 1,000. So that's not going to work. Oh my gosh, I forgot that that's a feature. Yeah, so right you seeing right here is that's the trainer. What it's doing is it's sending the board state from Python to this C# application. It's loading it in. It's doing some it's getting the board state and like converting it to a representation that the bot's can use. It sends it over back to the Python, and then the Python can build a tensor to train the model on. And that's what this is doing right here. It's probably like a bunch of different variations, a bunch of different positions are being played out really, really fast. It's a little bit scary. Um, but yeah, we might. Here, I'll take a look at what. I have some bots in here. I want to show some of them, but Megabox bot, Elo2 bot, Elobot 2. Okay, so this is one of the things that like you're trying to beat. It's called the tier 2 bot, and if you can beat this, probably in like the top few bots. Yeah, that's interesting. So what I'm seeing here is that the bot doesn't actually like use states. It does it it does iterative deepening. But it doesn't actually store them for reuse later. That's what my bot was doing, and I think that's what made it slower. Uh, one thing that I'm interested about is why it returns as a checkmate if I guess because we haven't fully searched this yet, so we don't want to go down it. That's interesting. Hmm. Hmm. Yeah, okay, so what I'm looking at here, this is an evaluation function with tapered evaluation using p-squared tables, this right here. We have a true TT entry. I already know how this could be optimized. We use a record instead. This is interesting here. Why they use this, I don't know. Well, okay. PST evaluation. I'm pretty sure this is how they change between end game and middle game for the PS. Yeah, yeah. Oh no, this is how they get. Oh, this is how they're extracting it. That is ugly. This is a search. This does have Q search. It also is transposition. Says move ordering, simple move ordering. Looks like it's a Negamax with alpha and beta. So this actually isn't too far from what I had as my bot. I just think that because it doesn't store it in memory, it's a lot faster. Which is interesting. Well, I mean, it kind of does store stuff in memory, like right here with the transposition table. I wonder what it's doing with these bounds. What is it doing with the transposition bounds? TT cutoffs. If it's not the root, it is the same key, and the entry depth is greater than or equal to this depth. Exact score. Entry bound equals 2. That score is greater than equal to beta. Lower bound fail high, upper bound fail low. I think what this is saying is that if it's, because this is a hard fail, so it doesn't like change it out. Oh, that's interesting. I'll have to use that. I think that probably makes it better. Okay. See, this doesn't seem too hard to implement. I've already implemented this. And then best move root. Oh, and this is how they do it? Oh, yeah. I could totally do something like that. I also want to look at some of these. 6-piece endgame database developed by okay, interesting. Let's look at search. Minimax, Negamax, Alpha Beta. These are depth first. We generally have these. And these best for search. B star. Interesting. I kind of want to take a look at these. Although I know it's not going to perform as well. I wonder what the base is upon. Alright, see, I would do that, except I don't think I have the ability to fit that stuff in. And that's all we have here. I'll take a look at... I know it's Monte Carlo Alpha Beta. Upper I already looked at that. Conspiracy, number search. Best first min-max. And B star. I did have a best first min-max, and it wasn't okay. It was not terrible. It did okay. It actually got 17th. It tied for 17th place in the tournament that the bot was in just like a few days ago. But they'd obviously lost to like the standard, but like the decently programmed standard ones. It beat the ones that were like not really the people who didn't really know what they're doing, I think, and like, or at least didn't really try too hard. But it didn't do too bad. But I want to do better. Why is there that image? I can't scroll up. Let's just read this. Enhancements to Alpha Beta based on null or zero window searches are none PV nodes. Proving already safe score from the principal variation. Also notes we need just a bound proven move is unacceptable for us or for the opponent and not the exact score. This is needed only in so-called principal variation, a sequence of moves acceptable for both players, not causing a beta cutoff anywhere on the path, which is expected to propagate down to the root. If a lower depth search has already established such a sequence finding series moves values greater now, the entire bands, chances are the deviating from it will do us no good. So in a PV node, only the first move, the one which is the best, is searched in the full window in order to establish the expected node value. We now have a PV node defined as a move raised alpha node. So we're going to stick with it to confirm our belief. We know or not. Null or zero window search. It says the move can be better. I don't understand this. PV search. If depth equals 0 quiescent search. So B search PV equals true for all moves. Make. If B search PV, we search it. We update the score. Blah, blah, blah. Unmake. If score is greater than beta, blah, blah, blah. If score is greater than alpha, then alpha equals the score. And then B search PV equals false. Return alpha. So if we find a move that's above the alpha, we instantly stop searching deeper. That's interesting. I wonder why that is. Hello, Redstoner. I'm struggling to figure out chess programs while waiting for this AI to train. this one here. I'm gonna see if I can find the light blue. Showcase. Show your bot. Light blue engine. Here we go. Let's take a look at this. Source. Bot V5. So what I'm do know, I still don't know what a no window search is. I should probably figure that out. And we can see here they don't store it in memory either, like I thought. Hello, JJ Crafter. Looking at, oh, there's a lot of, it's going good. Right now I am trying to code HSBot, obviously by the title, but I'm taking a look at other people's code to see what I'm doing wrong. While I wait for my AI to train. It's training right now. I'll test it in a bit. But yeah, it's going pretty good. Need help? I mean, I need help with a lot of things. Like how to just make a good bot, but not any particular problem at the moment. I'm trying to understand some of these concepts, like principal variation search, and, yeah, I know. And, what no window is. No window. So there's useless search space and alpha beta, like search from a Boolean test where the move produces worse, but the best value known. Okay. No windows were first described. Independently, no further elaborated. Okay, I just want to know what it is. Could you tell me what it is? Yeah, I know who. I do have Copilot. I applied for, I do know who you are, JJ Crafter, but I applied for GitHub Student, and I got it for free. So, yeah. Scout. Code eval, blah, blah, blah. Use purpose. Okay, what's the idea? Okay. A Boolean function called test, which is used to prove all siblings of the first brother were either below or equal to the max so far, or above or equal to the min. If the condition did not hold, a research was necessary to get a new min or max value. So essentially a no window search. Okay, but what is a no window search? Oh, not gonna tell me. Alright, we're asking ChatGPT. Thank you, Freddy, for wishing me luck. I'm gonna need it. Actually, Freddy, I don't know if you submitted, you didn't submit a bot to the unofficial tournament, but ArcNet actually got tied for 17th place. Standings. Look at the standings. Look. Like a ton of bots tied for 17th. Yeah, you got bored of making bots? Yeah, I'm close to it. I'm close to it right now. But I want to get something that at least is in the top view. Like, I'm bored of it, but I'm pushing onward to make something good. Right now I'm training AI, but the token limit is very, very exceeded, and so I doubt this is, yeah. 6-minute code. Yep. It is. It actually hasn't been training for that long. How long? I can't really tell how long the stream is. Oh, how long the stream's been going? 26 minutes. Okay, it's probably been training for like uh 30 minutes right now. It's on Epoch 5, um, which is it's the fifth time that it's going through its materials and learning. Um, but I should be able to right now after it finishes this last epoch, which it's almost done with. Um, I'm going to test it right now. Use Notepad? No way. I there's no chance I'm using Notepad. VS Code is so much better. So much better. It's not training. It's not reinforced. It's not training against anything right now. It's training. It's supervised learning. It's being trained on stockfish evaluations. Just code in a notebook. I actually have a notebook right here, but unfortunately, it's lacking the very useful feature of executing the code. Um, but yeah, I have a data set that I'm actively generating as it trains. Um, I call it small. It's actually not that small. And here's all the evaluations you can see. Here's the position in Fen chess notation. Here's the move, and then here's the stockfish evaluation. Oh, I just finished Epoch 5. Alright. Oh, if I could have a notepad, if I could have a notebook that executes code, like just that I write in it, that'd actually be like a best invention ever. I don't need a Jupyter notebook because it just got VS Code. No point in using it. Alright, we're testing it right now. We are playing chess against this AI. We're gonna see exactly how well it does. Okay. So, interesting thing about this move was I can just push the pawn. And we're gonna see if it blunders. Okay, no. That's good. It realized that it's gonna lose the knight. Oh my goodness. Oh my gosh. Bro, you moved the knight for a reason, bro. You moved the knight for a reason. Alright, hold on. It's a big brain sacrifice. Okay. It like saw like 90 moves in the future and it was like, it's checkmate in 102 moves. Alright. Here we go. Alright. Let's playing an interesting move that I see has no benefit. It already knows it. It already knows it's won. It is. Although, I already know I've won. Actually, I don't. I could totally lose this. I'm gonna try and win this, though. Okay. Big stockfish versus my bot. It's never gonna win. It's not even gonna have a chance. It's gonna lose instantly. Well, not only did it sacrifice its rook, it did not take back. I don't know anymore. I I this is beautiful. It's learning Stockfish 16 at a depth of 15. So the newest Stockfish version. But it appears to not have learned it too well. Because I am absolutely obliterating it in every sense. Is this checkmate? It is. the fact that I can beat the bot means that it's not good, because I have questionable chess ability. Let's put it up against a pretty terrible bot, and we'll see how well it does. Okay. Sacrifices the queen and the knight. You know, just standard stuff, and up against itself. All right, let's see it. Yeah, that's a thing. We're playing it. I'm playing it against itself right now. My bot versus my bot. I actually do have a my bot versus stockfish. Oh, well, I can't even explain some of these moves. I'd like to commentate, but I can't explain some. See, like, it has decent position if it wasn't blundering a piece. Like, look at this. This opening's not terrible if it wasn't like, blundering pieces. I'll play it against stockfish in a sec. But right now, I'm watching it absolutely. It checkmated. Nice. So, I don't know how much this is going to mean to any of you, but the bot is doing Monte Carlo tree search, and then its evaluation is just a neural network that was trained on stockfish evaluations. And all right, I'll play it against stockfish because it just played against itself. Let's see. The bot beat stockfish. Here we go. Interesting opening by stockfish. Very interesting opening by stockfish. I've literally never seen this played, and it it proceeds to sacrifice the knight. This is not stockfish on max capacity, because otherwise it would completely be obliterated. This is like the lowest setting that you can put stockfish on, and it's still obliterating it. Yeah. That's interesting. I thought stockfish was for sure going to put the queen on G2 and like attack the rook, but it didn't. I'm guessing it pushes the pawn to attack the knight. No, interesting. I don't know if I could even figure out how to use a quantum circuit for the chess bot, to be honest. I wonder why stockfish isn't taking the knight. Anyway, cause, I mean, what would a quantum circuit do, really, for this bot? I think it's already kind of failed. I mean, I could try doing a quantum ML, but it's not really. All right, I'm back from an absence. Um, this is rainfall sound, as the background. Um, it's, uh, it's some just rain music, and I think it has occasional, like, lo-fi and stuff. But, uh, yeah. Well, Actually, in a surprising turn of events, my bot is tied with Stockfish 1-1, but that's because Stockfish timed out. Not because not because my bot checkmated. It's raining there for real. It matches perfectly. um, we take what we can get every time. Yes, we take every win we can get. Um, yeah, I'll put on. I'll actually put on my old bot. We're gonna first just make a GitHub commit of this. We're gonna be more trained Monte Carlo. Let me pull to Negamax. Yes. Attempt Q search. Fixing. Eat square tables. Okay. This right here. Actually, hold on. I'm gonna copy this. I'm gonna copy this file right here. Is this the latest one? I want to go. This was yesterday, right? Yeah. View file and. Okay, I'm just gonna copy this and paste this in. Nope, oh, wrong file. I'm gonna stop that as well. Okay, so this is actually the better bot. It's much better, but it's not as good as the like the better and it's not as good as the better ones. Yeah, my dog's so cute. Okay, let's I'll let's play this. If you have any move suggestions, because I'm gonna need help. I'm not gonna be able to beat my own bot. But if you have any move suggestions, please tell me. So here we go. Standard E4 opening. It does not know any openings, so it plays very strange moves. It also likes to have this queen attack, like this. I think it's because it gives a lot of options if I mess up. You don't know how to play chess? That's okay. You'll probably do about as good as I'll do. Let's attack the queen. Of course, it does that. I think I'm already losing. I'm definitely most certainly already losing. It's not an I think moment. My position has been obliterated, and it's on the attack right now. One thing it likes to do is if it doesn't see any, like, especially good moves, it will just make, like, a weird waiting move, because it doesn't know what to do. And I think that's one of the reasons that it's not very good, bot-wise. And a lot of things fix that by adding what's called P-square tables, where basically, like, for pawns in the early game, they like playing in the middle. Yeah, it's playing good, but that's because I switched out the code to a non-neural network one. That's like a little bit more standard. But it loses to like the better bots, which is a little bit sad. How can I beat this? I don't know if I can beat this. I estimate it to be like around it's over 1,000 elo. I'm pretty sure. But I don't know exactly. Okay, it dodged the pin. No. If I do this, takes. Yeah, but that wouldn't do anything. Playing good now? Yeah. What do you want me to do with the rook? Might be able to... Alright. Thank you for taking a little bit of time to watch. I will. I will hopefully get a bot. Oh, shoot. Ooh. That is not good. I lost a piece here. Actually, I didn't. Right? Because I can just take, yeah. Oh, shoot, I did lose. Sometimes I don't see these things, but the bot pretty much always sees them. Because it's gonna search. It, like, checks all the moves. Let's see. I don't really see how I can win this. The knight could take the bishop. Here? Like if I went here and then here, but then it's defended by this knight, right? Oh, you're saying what's down here? Oh, when the rook was attacked? I probably didn't see it. But, well, I didn't see it. Better chess. Here. I'm gonna try this. I'm definitely good at chess. Hear me out. Hear me out. I'm good at chess. Don't worry. Um. Huh. It gave me a free bishop, a free knight. Interesting. I might have a chance at this after all. I'm gonna take that. Drop this down. Don't want to do that. And it's gonna take it. Yep. That was a good move. Yeah. Didn't take it. Interesting. Oh, well. That's why I didn't take it. See, now it's obliterating me. Oh. Checkmate's coming. Oh, it's stalemated. It's stalemated. I didn't lose. Oh my gosh. What? It's terrible. All right. Well, see, nah, not a win. It's a tie. If you don't know what a stalemate is, basically, I have no moves, but I'm not in check. Yeah. So we're gonna just delete. Yeah, it's a draw. Yeah, exactly. Okay. Yeah. I'm gonna delete all this code right here, and we're gonna just. I'm gonna just start writing a bot from scratch. Like, generally, hold on. I'm gonna just write like a bot from scratch real quick. Why did my audio die? W means draw? Since when? Because, W for win. Because is it W for draw? Because at the end it's a draw? At the end it's a W. So it's like a question mark. Oh, W with question mark means draw. Oh, I see. That's interesting. I did not know that. Well, it's time. It's time to write a chess bot from scratch right now. See how far I can get in about an hour, if that's how much time I have. I'm also going to turn up this music. Maybe that's a bit too much. Okay. So, what we do here is we need a search public. I don't need the public. We actually don't need a public. Void actually needs to be let's do int search. Might go get inspired by some code. No, or like take a look at it and get part of it. Okay, so int depth search the depth. We need alpha, it's beta. It is our code. Yes, it is. It is for sure our code. Okay. We're gonna set up a variable so I can reference the board later. So one of the parts of this challenge is you have to write as the least code amount as possible. It has to fit within this 1024 token limit, which is difficult. Yep, the code is in C#. I'm gonna steal a little bit of this code right here. Yeah, but it's not about the lines. It's about so it's what a token is, for example, this right here is one token. This name right here is one token. This semicolon is one token. And then right here we could count the tokens and go 1, 2, symbol is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this right here is 14 tokens. So you can use long variable names and that won't impact your token count, but if you use a bunch of variables, that does impact your token count. And one of the word count basically. But strings, every character counts as a word, so you can't really like put too much information in them. In fact, I don't know if anyone's going to use strings. It's probably better they just use numbers if you were to store information, but that's getting ahead of myself. I'm not there yet. Right now, what I'm trying to do is just simply get a valuation function in, which we do. This is a simple valuation function. Then just need to monotonous game of Monopoly. Hey. I think Monopoly is probably one of the worst games of all time. It is so boring. Like, maybe playing it once is fun, but after like a little bit, it's just unbearable. Like, it's not interesting anymore. That is a not very common opinion, I don't think. A lot of people really like Monopoly. Interestingly. Uh, um, one yeah, I also want to talk about how generally in I've been making my bots basically. There's like a tree of states, and I store that tree, and I can move down that tree. The problem is that being able to represent that tree uses a lot of tokens, um, and also it's a lot of memory, and so I think it's actually slower than just not having a tree and just using it as just doing a recursive function. And that's what like that's what like the other chess engines I'm seeing are doing, is they're not having like a class, which is a tree, a node, and then like represent as child, so we can represent like a tree, but instead it's just a recursive function, and so that saves a lot of tokens. Well, not it saves tokens, and it's faster. So I think that's what I have to do with. I've always been having this class tree mainly so that I can like reuse states over the next move, but I think it's just slower. It's just too much slower in general. Um, I don't know if that made any sense, but yeah, that's the thing. So take a look at this. Let's see. Moves equals board that get legal moves. So what I'm thinking here is we get the moves. Um, we loop over every move. Four, move, move, and moves. And we make the move. We do Negamax, which is I don't want to exactly explain it because it's still confusing for me. I don't know the best one to explain it, but basically, it's gonna choose the worst move for us, which is the best move for the opponent. Um, or yeah, the best move for the opponent every single time, and then it like oscillates strangely, and that somehow gets you a move that. Yeah. I don't know. I don't even know. I must just stop trying to explain something I don't understand. Uh, so if score is greater than or equal to beta, blah blah blah, then we can just return the output, right? That's how this works. For each state, expand. Score is greater than or equal to beta, we return the beta. Otherwise, score. Score is greater than alpha. The score is greater than. Yeah, we need to store max. Int max equals negative. Score is greater than max. It always gives the best move for the current player, not the worst move. I mean, it's. Yes, that's right. That's a much better wording than what I was trying to say. uh, yeah. We actually, can we just, yeah, we can return there. Actually, no, we can't. Yeah, we're just gonna, what we do is, we gotta do max equals beta, and then we just break. And then that way, so what we have to do is, actually, no. Because it makes the moves there. Yeah, we can just return. So this should be pure, this should just be out, this should work. Alright. This should just work, if I'm not mistaken. Well, actually, it needs to actually choose a move first. So we'll see, move underscore best move. And then, if, what we can do, if depth equals 0, best move equals 1. And then, so, yes, in this case, it should return max, but there's like two types of alpha beta. There's, fail hard and fail soft, and if I'm not mistaken, in fail hard beta, you can just return alpha. I believe. But I think what I'm doing here is fail soft. If I'm not like confusing myself, I should be doing fail soft alpha beta, and then we return the max instead. Yeah. And not entirely. The only difference between the two is I think it if the value is outside of the bounds, if the value is if the value is like yeah, what is the difference actually? I forgot. I completely forgot. Yeah, I'm here. I'll look that up right now. Alpha, beta, pruning, yes. Let's go to that right now. Okay, so blah blah blah. Max versus min, blah blah. Fail hard. Okay, so since alpha and beta act as hard bounds to the return value, if depth left is greater than 0 in the above code samples, this is referred as a fail hard. So it looks like in fail hard, if the value is out of a bounds, I think you need to do research, and I think this is called a null window or something. I thought that was for aspiration windows, I believe. And then outside of bounds may return scores outside the bounds is either greater or less than the alpha. As to keep it has to keep track of the best score, which might be below the alpha. Okay, so it looks like fail soft beta is like just slightly more code, and it's all it is doing is not limiting the score to be inside the alpha beta. So maybe a slightly more accurate evaluation, I guess. I don't know how much that helps. Really? Maybe it helps with the transposition tables, because it's going to be more accurate evaluation there. But yeah, okay. Let's see. Let me do this. So if score is greater than equal to beta, am I doing this right? Outside of bounds. If score is greater than equal to beta, depth equals best. But yeah, so this is if score is greater than best score, max equals score, yeah. And then alpha, if score is greater than alpha, yeah. Okay, why would if the score was less than alpha, then why would it be the best move? I guess it'd be like me at the first one. What do you mean you use an optimizer? Explain that a bit more. I'm not understanding. depth equals, no, if depth, okay, use the atom optimizer, but for what? Y plus 1, yes, 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 yes. If the value is outside of the bounds, okay. I'm gonna search to a depth of 3, with PLI at 0. And if depth equals 0, we return evaluate. This might just be a chess bot. I think a chess bot exists now. Let's play it. Nope, something happened. There is an error. Of course there is an error. Illegal no move. What do you mean illegal no move? Okay, that's what the atom optimization algorithm is. But why should I use it and where and how? I can't not understanding. Like, this right here is not a neural network. So to get to, but we're not doing gradient descent here. When it was about to get checkmated, yeah, that was probably, well, it's not about to get checkmated here, so that's what I'm trying to think about right here. Nah, I was not working on that anymore. Trying to make a simple handcrafted evaluation right now because the neural network's not going to work out. It's too big to fit inside this small bot. Yeah, the word count. And best move. Is it because the depth, the PLY, is never 0? Depth equals 0, return evaluate. Otherwise we get all the moves. Make move. If the depth equals 0, best move equals. Otherwise. What? Yeah, I will use it. Console.WriteLine. We'll do a depth of 1. Depth of 1. Console.WriteLine. Move plus 4. Also console.WriteLine here. Move.score. Let's see. B8 to A6. B8 to A6, yeah? The depth is 0, though. Oh, that's why. Because the depth actually needs to be 1. Because that's when it's actually a move. But the bot's making, because the root is technically a it's not any depth yet. There we go. All right, let's set this depth to a 3, and we'll take a look. I'm gonna delete this so that it doesn't crash VS Code from so many debug.logs. Yeah. Okay. So the bot brain is pretty small right now. We've got quite a lot of tokens actually to use, but there is an illegal move. H8 to H6? Why is that illegal? Oh. What? That's not supposed to happen. That is... Oh, that's why. We need to check if the PLY is 0. Not the depth. Because the PLY... The depth is how much left we have to search. The PLY is how far we've gone, and we only want it to be the best move when how far we've gone is 0. Because then that means we haven't gone at all. Yeah, there we go. And it's playing extremely quickly. Look at that. Look at that. Look how fast that is. That's beautiful. That is literally beautiful. Oh. It took a knight, though. Oh, because I trapped the knight. No, I didn't. I could have moved here. I guess it saw that I could trap it. Smooth. Oh my god. It's sacrificing pieces? Never mind, I sacrificed a piece. I'm continually terrible. Alright, this looks good. I think this looks good. I can't believe how much faster this is. No, I bet this. Okay. I'm gonna put this bot right now up against an old version of my bot, and we're gonna see how good they do. Board is draw. I'll do that real quick. Alright, I will be right back. Hello, Vitro Flare. Nathan, I will be right back. Give me 1 second. Okay, I am back. Um, and I am actually slightly worried. Um, I am actually slightly worried. Um, because it is so fast. I don't think this is possible. It is so fast that I do not think that it's possible. I'm gonna be honest. Either I did something incredibly right. No, I Spongey's bringing me a pizza actually. It's on its way. So I'm okay, so the reason I'm worried um is look, okay, never mind. The bot's taking a while. Maybe it's not that. Maybe it's not that crazy. Look at this opening though. Can we talk about this opening? This is an actual genuine opening. The bot's actually doing an opening. Oh my gosh. I can't believe this. I'm so happy. What is oh, as a matter of fact, okay. If you are every deity ever, does that mean that there's only one deity? Because if all deities are one person, then that means that all those deities are the same person, and that can be only be one of them. Oh, I see. Yeah, actually, I could do iterative deepening right now. Let me do iterative deepening right now. We'll do, um, while timer dot elapsed, is I may have accidentally muted myself. Yes. Well, if in case that did not, in case, I don't know, I don't want to say the name wrong, but in case you didn't hear me, you probably still won't hear me, but, because you're gone now, but, good luck on the presentation. But what I'm thinking right here, we sort the moves into move choice. So we evaluate, basically we get the moves, we evaluate an interest for all of them, and that's stored in a struct of move and interest, and then we order it by descending based on the interest, and then we just convert that to an array, and then the interest function we can do if move move if move equals best move, return no. So that way it will order it by that move first. For each move choice in moves, do move choices, and then we can do move equals move choice time. This should order it by the last move. Why are you using a struct instead of ordering it directly? Because I believe, okay, this is my belief, I haven't fully tested it yet. If we order by descending, and we pass in a function as this, my guess is that it's going to call that function every time it compares two of the elements. And so instead, if we store it as a struct and we store the interest inside of the struct, then it's only going to read the value instead of calling the function every time. That's my guess. I think that's how it works. Here, I'm gonna take a look right here at this, see what they do. For moves that get legal moves, move scores, and then it. This does incremental sorting. It does a one iteration bubble sort. Interesting. You keep switching. Ready 2. Yes. Alright, we'll test. Let's test. So right now it should be using the best move from the last iteration as its first idea. Is what it should be doing. And I can't tell if that made it better or worse. I actually believe that made it worse. Because it's taking longer. Because the sorting takes too long. If I completely get rid of this. It's not that it really makes it worse, it just makes it take more time. Which, I mean, yeah, see, it's slightly faster without the ordering. And that's why I think this person, I remember them talking about it, do incremental sorting. Here, I have an idea. Moves. Int move scores equals length we'll do moves dot select. Just to array. Yep. Okay, and then I'm actually just going to yoink this one iteration bubble sort move right here. Move scores is less than I equals 0 less than style length I plus plus, and then moves that's interesting. They do a one iteration bubble sort every time before they search? What? That's weird. That's actually really interesting. Okay, hold on. For int move index I equals 0. Move index equal, what am I doing? Move index less than 0, move index plus plus. Move equals moves move index. And then we can take this. We can do this. We can do move, same as to other move index. Other move index equals move index plus 1. Other move index is less than moves dot length. Other move index plus plus. Move scores index is less than move scores other move index. Then move scores moves index and move scores other move index. And this is weird. Okay, moves move index. Okay, so what I believe this is doing is it swaps it around if it should be swapped, and it's not going to fully sort the array, but it'll somewhat sort the array. What's the problem with this? It'll slightly sort the array every time, and then if it still needs to sort it more, it'll sort it more, I believe. Moves, move index, move scores, move index. Yes, okay. Okay, let's try this. Let's try this. Because I think what I was doing with the caching it all and then actually properly sorting it, it just takes too long to like fully sort the array. But look at this, taking a long time to sort just step 7. That's interesting. I'm gonna make it cancel out. Maybe add a debug to display the number of positions evaluated over the time to search. Sure, I'll do that. Let me do that real quick. Dot right line. Searched to depth. I can use the format feature. Hold on. Searched to depth in number.milliseconds ms. And then maybe we can start this a bit lower to get, I have a hunch I have an idea. Okay. So, I'm gonna record these values real quick. So these are the test values. I'm gonna paste this into this right here. And then we'll do a full. Wait a sec. Yeah, okay. Array.sort. Was there a way? Where's that sort? It'd be a good idea to replay the same moves. Yeah. I'm going to. It's boop boop boop. Boop boop boop. How can I sort this easily without changing too much? Sort array by key array. Yeah. I'll do that. I'm just trying to figure out. Yeah, I'll just make a git commit and then just rewrite it out. Read sample search. To struct record. Record goes first. Record struct move choice move interest move choices equals board deck for the moves that select move choice into earth. I'll do order by descending choice. I'll do choice on interest. And then we'll do for each move choice and move choices, and then the which is move choice dot move. Okay, so this is about how much time it takes. That's the thing. And it's this, and then this. Or wait. Yeah, okay. Let's compare the values here. So, it looks like sometimes it's slower, sometimes it's faster. Which is why you suggested looking at exactly how many moves it's searching. Well, it should search the same amount of moves, right? because it's searching the exact. It's not exiting early from the iterative deepening, so it's always gonna search the same amount of moves. And the time is really the only factor. It looks to be about the same. Oh, you're right. You're right. You're right. Yeah. Let's do that. Let's do that then. We'll do searched nodes equals 0. Is equals 0. Right line. Searched. Underscore moves. And then we're gonna see how many moves that it's actually searched. Real quick. So this is with the full sorting. I expect it to search less moves. So this is how many moves it's searched. And then if we go back to previous, which is this, and we add back search move, searched moves. The ordering function is just choosing the best move right now. It's really not that much, so I don't expect it to be too different. Yeah, I'll do that. Search move. Okay. It at least is coming up with the same moves. Okay. Okay, yeah, so the full ordering searches way less moves. Oh my goodness. It searches way less moves, but also it's slightly faster. Or slightly slower. Like, it's about the same time, but more moves. Which is interesting. So, I think the conclusion is that with better ordering... Huh. Yeah, we're gonna do a little bit of tests. A little bit of tests with the better move ordering. Yeah, I'm about to do that. Move, int, score. I imagine that most people are using ints because I believe they're faster for the operations. I don't know if it would matter that much. But yeah. Moves. Choice move. Choice is dot select. ending choice, move choice dot interest. Not interface. Interest to array. And then we'll do for each move choice, and move choices. Move equals move choice dot. Okay, and then we'll do the M least valuable, no, most valuable victim, least valuable attacker. I don't even want to try and figure out what the acronym for that is right now. Okay, if move that is captured, return capture piece type. Piece move piece type. This is it, right? This is M. I'm pretty sure this is it. That's what my guess. Right. This is it. This is it, definitely. I'll just look at this. We'll see how they do there. Or whatever. MVVLVA? I don't know. Yeah, MVVLVA. Now, this is my code. Least valuable. 1,000 times cap minus. Yep. Alright. Okay, we'll try that now. This is with full ordering. And the slightly better move ordering. It's definitely okay. This is the result. And then we'll do it with the incremental move ordering. And all we have to do to change that now is get rid of this. And what we can do here is well, we need to change this to index. So then we do for int move choice index equals 0, move choice index is less than move choices dot length, move choice index plus, and then move equals move choice one thing that I'm curious about is if they're sorting it incrementally, sorting it early. Okay, yeah, I see. For int other move choice index equals move choice index plus 1, other move choice index is less than move choices dot length move choice index plus no, other move choice. And then move choice in. We'll do this. If move choices, move choice index. This definitely uses a lot more tokens. I'll have that. So it's about the same. We're gonna use the one that uses less tokens. Temp, move choices, move choice index. Yeah. Here is the moment of truth, the deciding factor on which method's better. Okay, so they all searched to the same depth, and the incremental move ordering was ever so slightly better. Ever so slightly better. By like 20 milliseconds. Really not that much difference. So I'm just gonna do the full sorted one because it's a lot nicer to read. And there's really no difference. Okay. Least. Yeah. I wonder if we start at depth of 5. Yeah, exactly. So that's why I'm saying we use the one that has less tokens. Cause really there's no real need. Okay. Bot's looking good. What is the next thing I should do? Aspiration windows, maybe? Well, actually, no, we should do transposition table. Hold on. Feet, basic move. So, the two things I'm going to implement right now are 1, aspiration windows, and 2, transposition tables. And I'm going to do the transposition, actually, and 3, exiting out of the function early if the time allotment is up. And so if PLY is not equal 0 and timer.milliseconds timer what's an aspiration window where you said it? Okay, I'll explain it in 1 second. Let me just do this so that I have the brain power to explain it. You will return negative. No. Because we didn't fully search it. Do we want that? Sure, why not? Okay, yeah, and it exits basically completely as soon as well, now it's just dying. It's literally just sacrificing pieces. So we can't have that. It's playing infinitely worse. Return 0, that's a good idea. I just want to see if returning Returning 9999999 seems to be working. however. But I think... let's see what returning 0 is like. That's probably why it was playing so strangely. Yeah. Here we go. Okay. Good. So the next thing is transposition tables. I'm just gonna yoink some of that code from the old transposition tables that I had. Oh wait, let me explain what aspiration windows is. So the idea is you start the alpha beta off as a slightly above and below what the original evaluation was, and then if the value is outside of that, if you end up getting a number evaluation that's outside of that range, you have to research with the normal negative infinity to infinity alpha beta, and that just speeds it up because it has a lot narrower alpha beta usually, and then in cases where it does, it's not too expensive to recompute it. I mean, it's more of a gain than a loss, if that made sense. Record class. Okay, here is the transposition table right here. If transposition entry. Yeah. Okay, depth equals 0, return evaluate. Transposition, okay, and then int key, int hash equals underscore board. I get Zorbis key, right? Zorbis key, and then int key equals hash percent 100,000, and then the entry is going to be transposition table key, and then we can do if entry does not equal null, and actually a struct might be faster. If entry dot hash equals hash. C1. And entry dot depth is greater than and equal to depth, and entry depth greater than 0, then we will go ahead and return entry.score. And we also need to set that. So if So, okay, so if entry dot depth, well, actually, if our depth is greater than entry dot depth, and okay, then all we have to do is the transposition table key equals your transposition table hash depth score. All right. Entry depth is greater than or equal to depth here, or less than. Why would it? Well, okay. If it's equal to it, then the slot is already there. Do we want to overwrite it? Because that would just be unnecessary computation. And I believe that. Oh, okay. Yeah. Alright, we'll try it. We're trying it with the transposition table now. Oh, it got to a depth of 8, and man, transposition tables just are so much better. Look at that. Look at that. Interesting pawn push. One of the things that I like is that it actually finds this knight opening without any p-square tables. Which I think is crazy. Alright, we're about to add in the very last, what chess programming wiki calls obligatory change, aspiration windows. Do int, best move score. Okay, so I want to put in best move score minus 100 and best move score plus 100. Score equals. Boom. If score is less than or equal to best move score minus 100 or then equal to that, we have to recalculate. So then we do best move score that. What else we can say? Best move score equals score. And I believe that's aspiration windows. You can, just not too small. Right now this is about a pawn, and generally what is the bot actually playing itself in the background? No, that was just really outdated stream. Anyway, yeah, you can have a small window. Some bots they increase the window if it fails instead of just doing a full search, and that's usually does better. But for right now, I'm gonna have a small window and then just research if that fails. But yeah, you can't do too small of a window. But you can get away with. I was getting away with about 100 last time I tried this, so I'm gonna, or one pawn. So that's what I'm trying right now. Let's see if this helps. I can't exactly tell. This is one of those cases where we might have to fight the two bots, and then whichever one, like, wins slightly more. You know? But it appears to maybe be slightly faster. Well, yeah. This is actually, here. I bet that this right here is better than my old bot. Right now. This thing right here. And I'm gonna test it right now. So the black bot is my old bot right now. And the white bot is the new bot. And the black bot sacrificed the knight. Oh yeah. This bot is so much better. It's not even close. Dang. Look at that. That's a good ball right there. It sacrificed the queen? What was that? I mean, it's winning by a lot, but it's not winning by that much. Yeah, I can see. Okay, now it's losing, which is very interesting. Which one is your bot again? Is it the Negamax one? Is that the one? Okay. This is a very winning for white, yeah. Come on, just push the pawns. Okay. Well, they played better. Yours bot is the Negamax bot, right? This one? No, wait, no. Rider Rocks. Wait, do I have you? I have the Alpha Beta one by you. Alright, yeah, I don't have that one. If you want to send it to me, I'll bite it. Yeah. I mean, yours is probably going to win because I have Key Essence Search or whatever. Which is like a big improvement. Yeah, so I'll fight. I'm predicting that because I don't know how optimized is your bot, because this bot is, it has aspiration windows, which yours does not, so it might be able to find moves slightly faster, but you're gonna find better moves because of your aspiration window, because of your key essence search. So I'm guessing that if my bot does not win on timeout, it is going to lose because, as I saw, back in the the last game, it sacrificed its queen, just randomly, and I also think that might be because it's exiting out of the search early, when it and instead of reusing, wait, that actually, well, could it? Yeah, maybe. That might be. It might have been like a little bug of the exiting out early. I pinged you in your server. All right. I'll download this right here and import it. And I have two things. We can have it like play the game, and we can like actually watch it play it, or I can do like a fast threaded test, and it'll actually get the elo difference of our bots. Which one would you rather me do? TT entry cannot be found. There's errors. Why? Here's class. Interesting. What? Quick fix? Huh? I'm just gonna move this inside here. Oh, TE? Oh. Oh my goodness. Alright. That fixes it. Oh. It's funny. Alright, yeah, let's go to add this to the challenge control. Would you rather me like have it Q, would you rather me have it do a threaded one so we can get the actual elo difference, or watch it? New Rocks that. Watch a few. Okay, sounds good. Chess player. Okay. Let's just add my bot versus Rocks Q. And then my bot versus Frederick's Q threaded. Fast match. Okay. Yeah, that should be good. Let's watch it. Let's watch these two bots fight. Frederick's versus. Here we go. All right. So, draw by repetition. We might have a few of those. You know. Yeah, we might have quite a few of these draw by repetitions. It sacrificed the queen? Interesting. Best sacrifice of the queen I've ever seen. Oh my gosh. It's what the this is definitely where key essence search is helping the bot out. These sacrifices, these useless sacrifices. We'll leave the knight. The knight is lost. There goes the knight. Yeah. So your bot is definitely performing better. Without a doubt. Take the pawn. Yeah, they okay. Your bot is also way faster for some reason. Like, incredibly faster. I wonder why that is. You never taught never taught it to checkmate, huh? I wonder why your bot is so much faster. That's my question. Do you just put it on like a lower time, like does it just have a lower time allowance? Or like a specific depth it goes to? It doesn't use iterative deepening. Fixed depth of 5. Okay. So my bot is doing deeper than 5. It's doing 6 and 7, but probably your key essence search brings that out. Really levels that off. Yeah, horizon effect. Exactly. Exactly. Oh, your bot got a checkmate. Yeah. It looks like it's not too even of a match. Let's put ammo real quick, fast search. No. Fast game. 2-6. Okay. I'm gonna have him play a bunch of 30-second games, and we'll see. We'll see what the result of that is. I gotta turn off the console.write line, otherwise it'll absolutely spam it. All right, let's see the elo difference. Will my bot be able to win a single match? Let's find out. All right, it's running 12 games in parallel right now. Okay, it's currently negative 70 elo, plus or minus 92. So, you know, if my bot, could my bot get a single win? This is the question I'm wondering. Does your bot discourage draws at all? Because mine is not at the moment. No, it is. It is actually. Wait, hold on. Yeah, it is discouraging draws. I don't remember. Yeah. Yeah, I can just check. I don't know. No, it just looks like you're looking at mobility plus piece value. Yeah. So no checkmates or things. What? Hey! I mean, my bot is definitely losing. It wouldn't be there, you don't think? Not in the evaluation function? Oh, here it is. Okay, so if it's a draw, it's just plain. It's not discouraged. That makes sense. Well, oh, Stack Overflow. Interesting. I guess we'll just leave it at out of 46 games, your bot won 19. We drew 27, which means your bot's about 153 elo better, plus or minus 60. Yeah. 140, 150 elo better, looks like. So, yeah, makes sense. You might want if it had Q search. Here. Probably. Maybe. Maybe. What I want to do is I want to take a break from developing and go eat like lunch. And then come back and add like Q search. And then maybe one other thing. We'll see. See what's up. What's up next. So, yeah. That was interesting. Your bot is Q search. Yeah, so oh, have a good night. I was trying to do some unique approaches. See ya. I was trying to do like Monte Carlo tree search. I was trying to do a depth first search bot. I had a bot which it stored the whole tree in memory and then expanded the tree so it could reuse the searches from the previous move. Reuse the tree from the previous move. But all of them just did not perform nearly as well as like a standard approach like that. So I kind of want to try and go for competitive performance, make something, maybe it isn't the best, but at least is can compete, in the top, range, and maybe have a little bit of a tiny bit of a unique idea thrown in, but not really a whole new architecture. Because I've tried training neural networks, never worked out because there's not enough space. I've tried. I tried the Monte Carlo tree search with the neural network. That didn't work out. Without the neural network, didn't work out. Make the worst bot. Bad bot. I wonder if you could make a bot that is specifically designed to undermine to make moves for alpha that are worst for alpha beta and stuff like moves specifically designed to annoy other engines. Like, that's an interesting idea, but I don't want to do it because I feel like it'd be a lot of work. So if you want to take that idea, then go ahead. But yeah. So actually, probably right now I'm going for competitive. Not really unique idea. I don't really see. I mean, I probably could submit one of my bots for uniqueness, because you can submit two. Best first search bot. Yeah. 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 Thank you. Thank you for watching. It means a lot. It means a lot. Are you in the Discord server for that a lot of these people who are participating are in? If not, I can send it to you, and if you are, I was wondering if you participated in like the unofficial tournament they had like recently, and like how your bot did. You got an eye on the competition, yeah? Did you participate in the the tournament? Like, I got tied for 17th place, so not exactly great. Like I said, my unique idea does not perform as well as the standard bots, but it didn't do too bad. I thought it would do worse, but yeah. How did you participate, I guess, and how did you do if you did? Or what's the name? I can check right here. Yeah, this was you didn't? Yeah, yeah. Yeah, if you can come up with an interesting idea that just really does work and keep it to yourself, that might be what you need to win. But yeah, here I was, ArcNet, 17th place. I lost to Teeny Lynx. That's who I lost to. And, yeah. This, ArcNet, it was a... I believe what I submitted was a, best first search with a, neural network balanced evaluation. And it didn't do too bad. Interesting. Obviously, top half at least. So yeah. Anyway, I'm gonna stop streaming now. I'm hungry. Thank you for watching. See you later.